Alright, hi guys. This is another type or another special case that we might encounter when we're factoring. This is called the perfect square trinomials. So this sounds a little bit different, but it sounds also very similar to difference of squares, so don't be confused between the difference of them. So these are not factored any differently than normal factoring problems. However, the one big thing with these ones is that they can be rewritten as one parenthesis all squared. That's the goal. That's what we want to try to do. So it's either going to come in one of these two forms. I think we will discover those and we will deal a little bit more with those. So let's dive right into a couple examples. So example 7 says x squared minus 14x plus 49. So it says we're not going to treat this any different than a regular factoring problem. So I'm thinking about my factors of 49. So I've got 1 and 49, 7 and 7. Those are the ones that stick out to me big time. So 14, well, if I did negative 7 and negative 7, I would get my negative 14. And if I multiply them, I get a positive 49. So I've chosen the right factor pair. So this is going to be x minus 7, x minus 7. So I want you guys to think about, is there a way that I can write this even nicer? And hopefully, after we've done completing the square, that this is relatively, pops out at you guys pretty quickly. But I can rewrite this as x minus 7 squared. So that is what a perfect square trinomial is, something that can be written squared, one parenthesis all squared. Alright, example 8. We're asked to factor x squared minus 2x plus 1. Same thing, factors of 1. Well, 1 and 1. That was pretty easy. So think about your signs. What do you want the signs to be? If you want a negative 2, hopefully you're able to figure out x minus 1. X minus 1 would give me my negative 2x. The last step is you can write this as one parenthesis all squared. Perfect square trinomials are kind of fun. They're really easy. Just remember that you want to write it as you want one parenthesis in the end. That's the goal. You want one parenthesis all squared in the end. Alright, a couple more examples. X squared minus 24x plus 144. Same thing. We're going to start by factoring this. So 1 and 144, 2 and blah, 3 and blah. These you could definitely figure out, and if you'd like to go through and listen, you can. But I know for a fact that 12 and 12 will definitely give me 144, and that will also add to negative 24 if I make them both negative. So this would be x minus 12 and x minus 12. Remember, the goal is because they're exactly the same parenthesis, I can write it as x minus 12 squared. That is fully factored. That's as far as that's going to go. And example 10, 25x squared plus 20x plus 4. So, again, and I apologize for not bringing this up in the last couple ones, remember you always want to check for a greatest common factor. And look at 25, 20, and 4. We do not have a greatest common factor other than 1. And remember, we don't normally write that we're factoring out of 1. So from here, it's a couple different ways, depending on the way that your teacher taught, whether they used a box, whether they did the slide and divide or slip and slide method, or they just taught you to factor by trial and error. It doesn't really matter. You can choose any method, but I'm going to show the slide and divide method. So how that works is we're going to take the 25, and we are going to slide it back by the 4, meaning I'm going to multiply it. So I get x squared plus 20x plus 100. Alright, so from there, what we want to do is we want to factor 100 to add to 20. So we're looking for factors of 100 that add to 20. So there's a lot of factors of 100. Again, we could do 1 and 100, 250, blah, 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 blah. But I know that 10 times 10 would give me 100. So, and I know that 10 plus 10 would also give me 20. So this would be written as x plus 10, x plus 10. And then remember the last step in the slide and divide method is we take that number that we originally slid back. So in this problem it's 25. So what I'm going to do is divide both of these by 25. So this is where working with fractions and being able to easily work with fractions is going to benefit you big time. So 10 over 25. So we have to think about how we can simplify that. Well, I can divide them both by 5. So that would give me 2 over 5. And I can't simplify that anymore, so that's what I'm going to put in here instead. So we've got x plus 2 over 5 and x plus 2 over 5. Remember, if we can't simplify the fractions anymore and we are stuck, what you do is you take this denominator and you slide it back up in front of the x. So this is going to become 5x plus 2 and 5x plus 2. Remember, perfect square trinomials, we want two of the same in each parenthesis. We want the parentheses to match. Because if that happens, I can rewrite this as 5x plus 2 all squared, and that is all. So, just a little recap. This is perfect square trinomials. Difference of squares and perfect square trinomials are just two special types of factoring that we can do. Alright, I want you guys to pause the video here for 5 or 10 minutes, and I would like you to do these problems on your own, so please pause the video right now. Alright, let's review. So, first thing I'm going to do is I'm going to slide the 4 back by the 1, which means I'm going to multiply. So x squared minus 4x plus 4. Okay, so from here, what I'm going to do is I'm going to think about my factors of 4 that add a 4. Hopefully you don't think about that one too hard. That one's going to be x in 2 and x in 2. And because we want them to add to a negative 4, that means that both of my signs have to be negative. The last thing is, remember, if we slid the 4 in the back at the beginning, we have to bring it back in the end. So I'm going to divide them both by 4. Hopefully you can see simplifying 2 over 4 is a relatively easy one. So that would be x minus 1/2 and x minus 1/2. So that one's relatively simple. So remember, if we can't simplify it anymore, if we can't get rid of the fraction, you take that 2 and you slide it back out in front of the x's. So that would be 2x minus 1 and 2x minus 1. Remember, in order for it to be a perfect square trinomial, our goal is to make sure you have the same thing in both parentheses so that you can rewrite it as 2x minus 1 all squared. Hopefully you got that in your own work. So let's take a look at this last problem. So remember, in the slide and divide method, the first thing that we're going to do is we are going to slide that 9 back by the 16, and we will get 144. So x squared plus 24x plus 144. So we want factors of 144 that add to 24. We just did an example kind of like this earlier, so I hope this one comes back pretty quick. This one should be x plus 12, x plus 12. I wish we could say we were done. However, the last thing is, remember, we slid the 9 out in the beginning, so we have to divide it. We have to bring it back in the end. So simplifying fractions, we've got the fraction of 12 over 9. Hopefully you see that both 12 and 9 are divisible by 3. So this would become 4 over 3. So instead of 12 over 9, I'm going to write 4 over 3. So x plus 4 over 3, x plus 4 over 3. That's about as simplified as that's going to get. We can't really get rid of those fractions. So remember, if that's the case, we take the 3 and we slide it back up in front of the x. So we get 3x plus 4, 3x plus 4. Perfect square trinomial, we can write it as 1 parenthesis all squared. And we are fully factored. So remember, these are just tricks to help you with factoring problems. These are shortcuts. If you can see these and you can recognize that, that's awesome. However, if you need to go about and do it the long process way that we were taking a look at, that is totally fine. But thanks guys for watching. Do your homework.